All right, take it away, Cory.
All right, what's up, guys? It's me, Cory Martin, and you can follow me on Twitter at CoryAlexMartin if you want to. And like many of you, I make video games. And I've been making video games for about 10 years now. And most of these video games were made in a program called Stencyl. So this is what we're talking about today. Stencyl, making video games without code. So what we're gonna do, we're gonna talk about Stencyl real quick, like just a short keynote. And then I'm gonna open up Stencyl and try and make a game in about like 50 minutes to an hour or so. And after that, if we have enough time left, those of you with computers, you can download Stencyl. And there's gonna be a template game on my website you can download. And then we can use Stencyl. Okay, so what is Stencyl? That's a good question. Stencyl is a 2D game creation toolset available for Mac, Windows, and Linux. And the reason I wanted to talk about Stencyl today is because, if we fancy ourselves as game designers, obviously we have game ideas, right? And the goal is to take these ideas and make them into a playable form as quickly and with as little friction as possible. But what often ends up happening is you got this big freaking wall between you and the thing you want to make, right? And it might be because maybe you don't know programming, or you're new, or you focus in one field or whatever, or the tools you're using don't click with you. But what Stencyl does for a lot of people is it takes that big old wall and it makes it into something way more manageable. So it's feasible for this dude to climb over that wall or whatever, or kick it down, I don't know. And then he can play his cave story game that he just made on his GameCube with his Super Nintendo controller. And so an example of a game that might not exist if it weren't for Stencyl lowering that wall is this game Ghost Song. Ghost Song is being made by a guy named Matt White, and Matt White was an artist, and he didn't really know how to program, he never really made games before, but he found Stencyl, and now he's able to make this big old Metroidvania game that raised a bunch of money on Kickstarter. It's been greenlit on Steam, it's been talked about, it's been in conventions, I think. And there are more examples of this. This is just the best looking one. So, visual programming, who knows what that is? Yeah, okay. So visual programming is a way to program without having to actually type code. And there are a lot of different approaches to this. This is RPG Maker 2003. This is the first thing I ever used. I don't think it actually qualifies as programming, but it's kind of like visual programming. This is Construct 2. It's kind of similar to RPG Maker Zeal, except a bit more robust. This is Unreal's Blueprint Editor. That's a node-based system. Another popular node-based system would be Playmaker for Unity. And this is Scratch. So Scratch is used in a lot of educational institutions to teach kids how to code. So what you do is you drag these blocks into this, and you snap them together, and each one of these blocks represents a snippet of code and executes from top to bottom. So even though this is something little kids can learn to use to learn how to program, in my opinion, this is the best visual metaphor we have for coding. Because if you line code up right next to it, you can see a clear correlation. And I find that the process of using something like Scratch isn't that different from coding. So this is Stencyl. And you might be thinking, hey, Cory Martin, that looks a heck of a lot like that Scratch thing you just showed me. And you got me, it does. That's because in 2008, Stencyl was hey, Scratch is pretty cool. And Scratch was yep. And Stencyl's hey. So Stencyl was hey, can we do that? And Scratch was okay. So Stencyl did it, and now Stencyl looks like Scratch. So it's the same concept. You drag these blocks in, you snap them together, it executes from top to bottom, except Stencyl took this easy-to-use interface that Scratch uses to teach kids how to program, and it made it into something way more robust and way more feasible for making commercial quality games. So Ghost Song, most of the logic in this was made by snapping these blocks together, which is, I think it's kind of cool. Right. So that's Stencyl's visual programming language. Under the hood of Stencyl is the actual programming language is Hex, and that's also the compiler, and it uses OpenFL. So what Hex does is it allows you to write everything in one language, and then it compiles native code to a bunch of different platforms. So the supported platforms of Stencyl are Windows, Mac, Linux, iOS, Google Play, HTML5, and Flash. So yeah, with that out of the way, if there are any questions before I try and make a video game, you can ask them. Yeah.
What is Hack like?
What's that?
Is Hack similar to anything else, the language?
It's similar, I think, a bit to like ActionScript actually.
Okay.
And yeah. Okay, so now I'm going to open Stencyl. Oh, it's already open. All right, so now, okay, this is Stencyl. This is the Welcome Center. This is where you can create and open games. Sorry. Okay, so we're gonna make a new game here and call it, I don't know, cool video game. Okay, and when you make a game, you're brought to the dashboard. This is where you open and create and manage all your resources. So there are actor types. Those are like game objects. Backgrounds, fonts, scenes. Scenes are like rooms or levels or whatever. Sounds, tile sets. And this is where our logic goes. So behaviors are basically, you know, where you write your logic, your game logic. Okay, so we're going to start by making a new scene. Call this level 1 and choose like a nice vertical gradient. Yeah, it's okay. All right. And so now we have a scene, but we don't have any tiles or actors, so we can't actually like start designing a level. So let's fix that by importing a tile set. Call this tiles. And I have pre-made some assets that we can use. Right. Okay. And so if we set a shape overlay, we can see our collision shapes. So we only want the stuff that looks solid to be solid, so we'll do that. Right.
What kind of file type is your tile set?
PNG.
You just take a straight PNG
Mhm.
that's sliced up.
Yeah, and then you can set the grid size, basically. Yeah. All right, so we'll make like a little test level. That. All right. Now what we want to do, well, if we test our game, I'll show you that it will actually run, and then it should be a static image of a level. Right. So our game's not interactive yet, so let's make a new actor and call it player. This is the thing we're going to control. So import a new animation here. Sorry, like sometimes windows won't fit on the projection, but yeah. Import our player, call this right. Yep. And then we want to change the collision shape a little bit, make it a little bit smaller. Right, then we can nudge it. Okay, and so we have a right animation, or like a right idle animation. I guess I should call it idle, right? And if we want a left one, we can duplicate it. You can't see that menu, but you can flip it horizontally. And we'll call this idle left. Right. Then duplicate this, call this walk right, and then import a walking animation. And we can set the how many times we want to subdivide this image to make up the animation. So there are 3 of them. We'll set set the rows, no, columns, sorry. Columns to 3. And there we go. We got like this little janky animation that I made. We can speed it up a little bit. Then duplicate it, flip it horizontally. Walk left. Okay. So here we go. Now on our physics page, we can like change the physics setting. So no rotation. Rotation would be very silly. No friction. We're going to implement our own slowdown, so we don't want that. Okay, then we want to set the group of the actor to players. So a group is basically a way to categorize an actor or a collision shape in the collision system. So you can define which groups will collide with other groups, and that's what that's for. All right. So now let's make some game logic. We'll create a new actor behavior and call it walking. Right, so here's design mode. This is where you do the programming stuff. We'll add a new event, a when updating event. So an event, anything in this always block will update 100 times per second. That's kind of like the pace that game logic and Stencyl runs at. So an event basically defines when a certain set of code will execute. So always, bring in some conditional blocks. Right. So we want to detect, for walking, detect the player input. So we'll do if right is down and not left is down. Right. Okay. Then we're going to do the opposite for left. So if left is down and not right is down. And then add some movement code. Right, so we'll set our x speed. We're going to create a new attribute. An attribute is basically like a variable, so it's a way to store information. You can do that by going to the attributes section, or you can hit Control B. So we'll name this walk speed. And there are different attribute types. We'll do a number because that makes sense. And we'll make it not hidden. So if an attribute is not hidden, you can configure it from like the actor page. Okay, so set x speed to walk speed if right is down. Otherwise, so if we want it to go left, it needs to be a negative value. So we'll do negate walk speed. And if left or right isn't down or whatever, we'll make the player stop. So set that to 0. You can barely see that, but sorry. Okay, now we want to do like some animations. So switch animation to walk right. Under left, do walk left. And so for our idle animations, we want to be able to track which direction the player is facing. So we'll make a new Boolean. A Boolean's like a switch you can flip on and off, basically. Call this right. So if right is down, set right to true. Left is down, set right to false. Okay. Then, if right is true, we will switch animation to idle right. And otherwise, idle left. And there we go. I think that's good. So if we attach that to our player, and set our walk speed, we can set our walk speed, since it's unhidden, set to like, I don't know, 25. And we can add our player to the scene now. Cool. Actually, I also want to make a quick camera behavior. So like the camera will actually follow the player. Pull up camera. Okay, so this behavior, okay, there's this block here called always active. What the always active block does, or actually, so by default when an actor goes off screen in Stencyl, it'll stop actually simulating, so it'll freeze there and none of the code will execute anymore until it's on screen again. So if you make it always active, then it'll start, even if it goes off screen, it's still gonna run. And that's important, like, for a camera, like if our player starts off screen, we want this camera code to run. So So we'll attach that to our player, go back to our scene, and set some gravity so we will fall, and test our game. Right. All right, so now we can walk around and stuff. Okay. Right, so I don't know if I said this, but we're making an action platformer. So if it's a platformer, we need jumping, right? So let's make a jumping behavior. Oops. Okay.
So once you create these behaviors, can you then add them to different objects?
Yeah, so behaviors are reusable, like you can attach them to whatever actor you want, like, yeah. I actually have a reference sheet because some of these behaviors are kind of convoluted, so. Right, so in order to initiate the jump, we only want to do that when the player's on the ground, right? So we'll make a Boolean called on ground. Oops. Right, so on the ground. And how do we detect if the player's on the ground? So we have to set this true to somehow, or to true somehow. So we'll make a new collision event. This actor collides with something else. And we'll do bottom of the actor was hit, set on ground to true. And right, so this event will only run when it collides with something. And then we detect if it's hitting the bottom, and then if it is, set on ground to true. Right. So to initiate the jump, the player needs to hit a button. So action 1 was pressed, and we do was pressed as opposed to is down because is down is the active state of a button being held down, and was pressed is the moment it's pressed. Well, okay, so if they press the button, we want to make sure they're not on the ground anymore. So we'll set the Y speed to their current Y speed, or I'm sorry, the Y position, their current Y minus 1. And minus 1 will move it up 1 pixel because in Stencyl, up is negative. All right, and we want a new Boolean called jumping. This is basically to track if we're in the active state of jumping. So set jumping to true, and we'll make another attribute called jump timer because we want to limit the player's ability to jump. Like we don't want them to just hold the button and forever ascend into the heavens. So we want to make our own like little jump timer to limit that. And we'll set jump timer to, we'll make a new attribute called max jump time. And this one will be unhidden, so you can configure this from like outside of the behavior. Right. Okay, so that's how we initiate the jump. So if jumping is down, or rather if jumping is true, and our jump timer is greater than 0. So if it's positive, we will check if action 1 is in the state of being held down. So this is so the player can control the height of their jump. So yeah. And if they are holding it down and the jump timer is greater than 0, we're going to set our Y speed to a negative value, so it will go up. So we'll make another attribute called jump speed. Right, and then we'll decrement our timer. So basically just subtract it by 1. Whoa, that is strange. Okay, So we want to handle what happens when the player releases a key while they're jumping. So if they're jumping and the action 1 button was released, also, so what we want to do is if they're ascending and they release the key, we want to kind of make them slow down really quickly. Otherwise, they'll won't feel that good to play. So if they are ascending, so we can get that by y speed. If y speed is less than 0, so if y speed is negative, that means we're going up. Then we will set our y speed to our current y speed, and you're gonna have to trust me on this. We're gonna divide it by 3 because I don't know. When I was making this, I determined that feels good to play when it's divided by 3 when you release the key. I don't know. I can't explain it. Right, and then once this key is released, we will set jumping to false. And then one last thing, since our on ground, the moment we touch the ground, on ground is never going to stop being true. So at the end of our always event, we're going to set it to false. Okay, so provided I did everything right here, and I'm pretty sure I did, we can attach that and set our max jump time to 20. So 20, because always updates at 100 times per second, 20 will be 0.2 of a second. Our jump speed, 50. Okay, now if we test our game, we can jump, and we can control the height of our jump. So there you go. Neat. Okay. So I did say this was an action platformer, and it is a video game, and what do you do in video games? Well, you shoot stuff, so we need to make a shooting behavior. Okay. So this is a basic behavior. Oh, I forgot a step here. So we want, in our shooting behavior, we want to access, we want to know which direction the player is facing. So, and we have that information in the walking behavior, and we could access this from this block, but what we want to do to make it easy is set an actor value called right. An actor value is basically like an attribute that can be accessed easily from any behavior. So it's in the scope of the entire actor, rather than just one behavior. So we will set the actor value right to this behavior's Boolean right. And now, if right is true, then yeah, so now we can basically shoot left or right depending on which way we're facing. And so we want to create a bullet first off, but we don't have a bullet, so we need to make a new actor. Call it bullet, and import some animation. There it is. Okay, call this right. And we're going to change the collision a little bit, make it a little bit smaller. Oops. Right. And then nudge it down. Okay. Here we are. Oh yeah. This also needs to be a sensor. So a sensor is basically a collision shape that'll detect collision, but it won't actually physically interact with anything. So this bullet won't hit something and knock it over or whatever. It'll just detect whether or not collision happened. So we have our right animation, make a left one, flip it. Okay. So physics settings, no gravity, no rotation.
So if you put gravity, would it arc down?
Yeah, basically. So you don't want to have gravity. Unless you wanted it to. I mean, so yeah, we want to set the group to something, but we don't really have anything that's appropriate for a bullet. So we're gonna make our own group, like a new one. Go to settings and then go to groups. We can create a new group called projectiles or player projectiles. And we want something to shoot too, so we want to make a group for enemies. So we'll call it enemies. And player projectiles will collide with tiles and enemies. And enemies will collide with players, projectiles, and tiles. Right. So we set our group to player projectiles, the one we just created. And go back to shooting. And now we can create our bullet. And it wants like a coordinate to spawn it at, so since it's the same size as our player, 32 by 32, we can just set its x and y to the x and y of the player. And we want to make it move, right? Because it's a bullet, and bullets are only useful if they move, I guess. So make a new attribute called bullet speed. So set x speed to bullet speed for last created actor, if right, and if left, so otherwise, set it to negate bullet speed, so it will go left. I think that's good. So attach that to our player, and test our game once again. So now our guy should be able to walk, he should be able to jump, and he should be able to shoot. Whoa, what just happened?
Did you set it to a button where you could shoot?
Oh, that's right. Yeah. I didn't set the button. Thank you. I rehearsed this many times, believe it or not, but I still keep finding ways to screw it up. Yeah. Right, so if action 2 was pressed, I was very confused why your player became a bullet. Okay, so now it should work. Oh, why isn't that working? This is a joke. Something ain't right, y'all. Okay. Well, it doesn't work. That's it. Bye. This is very, very confusing.
Is there any way to inspect objects as you're running it?
I think I might have done something in the physics settings.
Where does bullet speed get set on that?
Oh God, that's right. I forgot to set the bullet speed. Thank you. Oh man. Yeah. That's why, because I accidentally made it hidden. That can happen sometimes. Right. So if we go back to our player and we refresh, now we can set our bullet speed. And we'll set it to some ridiculous value like 176. If your game doesn't feel good and it has shooting in it, make the bullets faster. Trust me. Okay, there we go. So now we can shoot. Well, I also need to set the animation. I forgot that. So switch animation to right. Switch animation to left. Okay. Now it should work, and I'll remember to move it over to where you can see it this time. Okay, there we go. So now we can shoot projectiles. Okay, so now you saw like we were shooting projectiles, but they were kind of going through tiles, and I don't want that. So we're gonna make a behavior for the bullet. We're gonna call it bullet behavior. And this is where we're going to handle like the bullet collision and stuff. So we'll make a new collision group. When this collides with, an actor of tiles. So if it hits a tile, we will kill it. And also, since we're going to have enemies, we want to think ahead and do one for enemies. So if this hit an enemy, but if we hit an enemy, we don't just want the bullet to just go away. We want to tell the enemy that it just got hit by a bullet so it can pretend to die or whatever. So we'll do a trigger event block, trigger event damage, and all behaviors for the actor of group. So, right, so it's going to tell the enemy that it just got hit with the message damage. And one more thing. Right. So when the actor or when the bullet goes off screen, we want it to stop existing. Otherwise, it's just gonna ruin our frame rate probably. So attach that to our bullet, and now you should be able to see that our bullet's gonna like hit a tile and go away. And it does. Cool. Now let's make an enemy. So it's like there's actual challenge to the game. Make a new actor type called enemies, or enemy. Import the animation. Call it right, and speed it up a little bit. Okay, and we'll make this less tall, maybe like 30. All right, and do one for left. Set some physics settings again. No rotation. Don't leave rotation on. It's just stupid. Like, stuff will happen. Your guy's gonna go tumbling everywhere. It'd be funny, but it would take up too much time. It'd make me frustrated. All right, no friction again. Disable continuous collision detection. That's like a performance-related thing. So like you have like a super fast actor and it goes through something, but it doesn't actually exist on the same collision as the object it's going through for like a tick of the game. Then it'll pass through it. But if you have it on, then like you can prevent that from happening. I probably didn't explain that well, but just know that it's a thing. I don't know. And set our group to enemies. Cool.
Does that make a big difference in the performance of the games?
Well, it depends like on how many collisions you have going on and how many actors. So yeah. But yeah, it's like a good thing to keep in mind. Like, if something's not performing well, you need to question like whether or not the physics settings are like, just choose what's necessary for your actor, basically. Mm-hmm. Yeah. Okay. So we want to make a health behavior, so we can shoot the enemy and it will die. So make a new one called HP. I want to say if anyone's trying to follow along, you probably shouldn't because I'm going super fast, and there's going to be like a thing afterwards where it's interactive. So like, yeah, just want to throw that out there.
You already lost it.
I probably should have said that beforehand. Yeah, like I've been speedrunning this the process of making this specific game for like the past week or two, so I'm pretty fast at it. Right, so our HP behavior. Right, so in our bullet behavior, when it hits an enemy, it says damage, like it tells it just got damaged. So we'll make a new custom event, and we'll call it damage. So when damage happens, when it hears the message damage, the code within here is going to execute. And so since it's an HP behavior, we want like an HP variable or whatever. So make a new one called starting HP, and another one called current HP. Right. And when created, so when the actor is created, we will set the current HP to the starting HP. Okay. And back here in damage, when this hears the message damage, we're going to decrement our current HP by 1. And then right after that, if it's been lowered to something less than or equal to 0, then we want to make sure that the thing dies. I know it's very sad, but it has to happen, guys. Great. So if current HP is less than or equal to 0, we will kill the actor. Okay, so now we made like a functional HP behavior, but that's not good enough. So when you shoot the thing, I want it to flash white, so there's like feedback that you just hit it. So we'll apply an effect. Adjust brightness by 100%. That'll make it turn white. But we don't want it to stay white, so we'll make a new number attribute called effects timer. And we will set it to like 10, so it'll flash for 1/10 of a second. Go into updating. So if FX timer is greater than 0, we will once again decrement this. And then, if it equals 0, like once we decrement it, if it suddenly equals 0, we are going to remove the effect. Okay, that should be good.
Should it be enemy.self?
What's that?
Should it be enemy.self?
What are you, I'm sorry?
Should it be enemy, not the self? Remove effects?
No, for self, like because this is going to be attached to our enemy.
Oh, okay.
So when, yeah. Right. Okay, so if we attach that to our enemy, set our starting HP to 3, and add our enemy to the scene, test our game. Right. All right, it works. Cool. So now we can kill things. So now it's officially a video game. Right, so now we want some challenge in it. So if we were to, I should have shown that. If we were to run into our enemy, it wouldn't damage us. And we want to fix that, right? So yeah, he's just going to be pushed. Right, so we're going to attach our HP behavior to our player. So we can reuse this and set our HP to 1. Because when we hit something, we want it to die instantly. Okay, and now we want there to be a way for the enemy to tell the player that it just took damage. So we'll make a new actor behavior called damage player. And a new event. When this collides with a member of the group, players. Trigger the event damage for the actor of group. Okay, so attach that to our enemy. And so right now our player is probably going to die when we touch an enemy, but we want the scene to actually reload so the player doesn't have to close and reopen the game. So we'll make a new scene behavior. Before we were making actor behaviors, we can actually make behaviors that attach to scenes. We'll call this reload on death. That's a good word, respawn. We'll do that. Respawn. All right, so we'll track whether or not the player is alive. If the actor is not alive, and we want an attribute for the player, we'll call it player. Make it an actor, make it unhidden. So if the player is not alive, we will reload, fade out for 0.3 seconds, fade in for 0.3. And also, since it's a platformer, like if we fall in a pit, we also want to reload. So we can also add that in. So if the Y of player is greater than the scene height, and we can drag in an OR block, oops. Okay, Stencyl sort of, it can be kind of hard to use sometimes when you're using it in a very tiny window. Oh my gosh, this is terrible. Okay, there we go. Okay, and we also want to make a Boolean to track whether or not we're already reloading, so we don't just like spam this same code over and over and over again. Right, so set reloading to true, and to prevent it from running more than once, if reloading is true, stop. So when it gets to the stop block, it'll stop running the code, everything below it won't run. And also, one more thing. I'm gonna do like a delay, so you can sort of revel in the fact that you just died. It's a little tiny delay of 0.3 seconds. Should be good. So if we attach that to our scene, choose our player. There are more ways to get like whether or not the player's in the scene. You don't always have to like choose it, but this is like a very easy way. Right, so if we test our game, hopefully when we die, the thing should reload. All right, so we run into the enemy, and we die. And it reloads, and if we fall off, it'll reload. Cool. Okay, so we've got our enemy, and we've got like shooting, and we've got reloading and death and stuff, but our enemy's not doing anything. It's not very smart at the moment. So we're gonna make an enemy AI behavior. And when I say AI, I use that term very loosely because it's just gonna be like a Goomba that walks back and forth, and when it hits a wall, it's gonna turn around. Right, so if right otherwise. So this is kind of similar to our walking behavior for a player. If right, set x speed to the positive value, we'll make a new attribute called speed. Okay, and if it's not right, then it's left, so set x speed to negate speed. And we'll switch the animation to right, under right. And under left, switch to left. Okay, so now it should move, but like we want it to turn around when it hits a wall, right? So we'll make a collision event. This collides with a tile. So if the left side was hit, otherwise if the right side was hit. If the left side was hit, that means we want to start moving right. And if the right side was hit, we want to move left. All right, cool. That looks like a very good artificial intelligence behavior. I think. Okay, so set the speed to like, I don't know, 17. And we test our game. So now our enemy dude like walks back and forth. Oh, I done screwed up. I done screwed up somehow. Oh, there we go. That's the problem. Right, so if the right is hit, then we want to set right to false.
What's that keyboard shortcut that we use to run the game?
Control Enter. Yeah. Oh man, I actually had like this program that showed like all the shortcuts I used, and I forgot to open it. But I don't think it would fit on the screen anyway. So, okay, so cool. Our enemy walks back and forth and stuff. Yeah. One more thing. So when the enemy goes off screen, it's basically going to stop functioning. So we want to make always active behavior. It's very simple. When updating, make the actor always active. And since it's an always, it won't become active until it appears on screen for the first time. And that's exactly what we want. Okay. Right, so now like we have this functional video game sort of, I guess. But we can do some more stuff, like add sounds and like when things die, like just make them not disappear abruptly. So we'll import some sounds here. Take one for damage. Another one for death. Another one for when the bullet hits the wall, or hits like a tile and goes away. One for jumping. Oh. And one for shooting.
What kind of files are you recording?
What's that?
What kind of files?
These are MP3 files. So if you're making a Flash game, which we're doing right now, you want to use MP3. For everything else, you want to use OGG. Yeah. Okay, so now we'll apply these sound effects. It's very simple. Just use the play sound block. Right, so one for damage, put that down here. One for death, put that here. Open up our bullet behavior also. So I closed a bunch of stuff. So when this hits a tile, we also want to play a sound. And one for jumping. Finally, one for shooting. Okay, so we have our sound set up, and I could test the game and show you, but I want to do more stuff. So like when stuff disappears in the game, like it's just kind of disappearing and it's very jarring. So like if Alex here disappeared abruptly, you'd be like, what the heck, he just disappeared. But if he disappeared and turned into a puff of smoke, you'd be like, oh, okay, that's normal. Right? So we want, when something dies, we want a big old bunch of smoke particles to go everywhere. So we're gonna we're gonna make a smoke actor. Okay, and this does not need collision. No gravity, no rotation. No continuous collision detection. And we're going to set the group to doodads. So doodads are like a special group that will never collide with anything, and like that will really, really help our performance. So like we could have like hundreds of these things and like it'll be like perfectly fine. Okay, so we've been making behaviors this whole time, but there's also this tab in your actor called events. So events are basically for like one-off things that you're only going to use in this particular actor. So anything in here, like you're not going to be able to reuse it. So this is good for like really quick stuff. Right, so our smoke is going to start off big and then turn small over a period of time. And we want that period of time to be random. So we'll make a new attribute called RNG. It's going to be a number. RNG stands for random number generation. So we will set RNG to a random float, and like a floating point is a number with a decimal place between 0.5 and 1. So between half a second and a full second. And also, when it grows, like it's going to shrink down, and when it shrinks down to where you can't see it, we want it to die. So also do after RNG seconds kill. Right. Okay, so now we want like a behavior for spawning this smoke, right? So we're going to make a new scene behavior and call it smoke spawn. Okay, so all this time we've been using all of these blocks that are built into Stencyl, but you can actually create your own blocks. So we'll go to Advanced, go to Global Custom Block, and now we can basically make our own block from here. So we'll call this smoke spawn, and you can define what values you want to accept in the block. So this one, we're going to have one for the actor, call it actor. I spelled it wrong, that's okay. And one for amount. So we want to know how many smoke actors we want to spawn. Okay, and then we can, and here we can type what appears in the block field. So spawn, or create amount smoke for the actor. Right, so now we have this cool little block here that we can use. And every time we use this block, the code in here will execute. And we have like these values right here to play with. Right, so create smoke at X and the Y of our actor value. And then we want it to go in a random direction at a random speed. So go to motion, set velocity to random integer between 0 and 359 degrees. So that'll be a full 360 degrees. And set the speed to a random integer between 5 and 20, I guess. We want to make sure we do that for the last created actor. Okay, also, we want to repeat it for the amount of times that we specify in the amount field. So repeat amount times, and then it'll just run this the amount of times you specify. Cool, and we don't need to attach this behavior to anything because it's using a global custom block, and those are just, like this behavior serves the purpose only for defining this block. Right, so we want to apply that. We want to use that block. So we go to custom blocks. When something dies, we will create 15 smoke. And also, when our bullet dies, it'll create 3. Because that's a cool number. Okay, so now if we test our game, hopefully there should be sound, and also when we shoot things and stuff dies, there's going to be smoke. So there is. Cool. Oh, I'm sorry. Not again. Okay. So right. Now we got our smoke effect, right? And that dude died. And there was smoke. So there you go. Look at that smoke. Wow. Okay. So now we can like get on to level design. But so Stencyl uses Box 2D as its physics engine, and Box 2D is cool, and like you can do a bunch of physics stuff with it. So to demonstrate that, I'm gonna make a new actor called Barrel. And import our barrel graphic. Yeah, rotation, gravity, heck yeah, it's a barrel. It can do whatever it wants. And we want to set a group, but we don't have a group for a barrel, so we'll make a barrel group. Yeah, the barrel gets its own group too. Call it barrel, and then barrels collide with players, they collide with tiles, they collide with other barrels, and they also collide with enemies. Okay, now we made a barrel. Cool, and we can use that. Okay, so now is when we design our level. You can expand your scene by like using this cool tool, or we zoom out, you can just set the width to like 120. Cool, so now we have a bunch of space to work with. So this little tool will like show you what the player can see when it's at a certain point. So we can position our enemy right off screen. Like, it's like a platform or something, I don't know. Some dudes up here. Have like a platforming section. Cool. I do not recommend doing level design this hastily.
Will the enemy walk off the edge?
What's that?
Will the enemy walk off the edge?
Yeah, but these guys are going to move left by default, so we're planning for that. Let's make like an area over here. It's like, yeah. And then maybe like, there's this wall right here that's too high. Uh-oh, how do you get over the wall, man? I don't know. Well, barrel, of course. Right, almost done here. And they go like down here and like this cool cave or something. Use your imagination, people. That's why I made these little graphics here, so you can see that it's definitely a cave. Oops. And then like they get out here, and then like they're ambushed by like a bunch of enemies from above or something. And like some dudes down here also. Okay. And finally, you get to the end, and you get like a cool victory platform. Yeah. And oh, we should add some more enemies to make it more interesting. Alright. Then at the end, like, I don't know, barrels. Okay. So, hopefully we have a playable level here. Okay. like over here. Oh man, I can't jump it. Puzzle. There we go. Whoa! Oh, why didn't you collide with the barrel? What have I done wrong? Oh man, that was supposed to be the big barrel reveal. I didn't set it to barrels, man. All right. It's all good, guys. It's all good.
Can't see it.
Oh, again. Right.
So if it touches you, what happens?
You don't want to touch it. What's that? Yeah, so basically it's just going to reload the scene. That's how the respawning's working. Yeah. Okay, puzzle. Barrel. There we go. That's Fox 2D, people.
How do you set like the number of lives you have?
What's that?
Number of lives.
Well, you could do that with like a... Oh, what have I done? I wanted to play with the barrels, man. It is very important that we play with the barrels. We want to relish in our victory. Okay, then we get like cool barrels, and then like, I don't know, it's a video game, do whatever. Uh-oh. So that's our video game that we just made.
What's it called?
It's called Cool Video Game. That's what we named it. So yeah, if there are any questions, like before we do like the interactive bit, assuming we have time. All right.
Can you write code if you want to?
Yeah. So you can go in here, and when you're creating behavior, you can go to code mode, and right. So then you can code. And also, like something that's cool is if you open up a behavior, and then like there's this button down here for, oops, not that button, for code preview. So you can see like the code that's actually generated by these blocks here. And also, there's a nifty feature. You can right-click this and view code. So there. And then, like, it'll just show you like the code of any block that you.
And what language is it?
That is hex, H-A-X-E.
It's really close to ActionScript 3.
Right. Yeah. Any other questions?
So the game is currently set to Flash. Is there anything else you can put on?
Yeah, so up here we have a bunch of platforms we can export to. So Flash, HTML5, Mac, Android, iOS. And if you're on Windows, you can do Windows, and if you're on Linux, you can do Linux.
Have you used Construct?
I have not used it. I've looked at it and stuff like that. So the thing about Construct 2 is I hear that it's not as powerful as Stencyl, but it's good for like starting out. So Construct, the way I understand it is it's basically no matter what platform you export to, it's an HTML5 wrapper. So it's not actually running native code. Yeah.
I'm curious, so you seem pretty familiar with the Stencyl drag and drop kind of interface. Do you know any programming languages?
Yeah, I know. I can like code a little bit because like I started out in like 6 years ago when I started using Stencyl. It was like exclusively just design mode, the visual programming. But over the past like few years, I've gotten like messed around with Hex and done some stuff in Unity. So like, and sometimes I do code behaviors.
I was
Yeah.
just curious what the time difference between needing to go and find all your blocks versus if you know a programming language,
Right.
what seems easier.
So coding is definitely faster if you memorize, if you memorize the API and you know the syntax, like that's definitely going to be faster because like you can type faster than you can like drag stuff in. So, but this is good because you don't have to memorize like an API reference or whatever. Yeah.
And how does this compare to being a
Well, I haven't used Unity extensively, but one thing I really like about Stencyl is it's tile-based. So doing tile-based stuff in Unity isn't so fun from what I've seen. And yeah. So like it's basically whatever works for the kind of games you want to make. All right. So now, how much time do we have left?
It is 40 minutes.
Okay, cool. So, who here downloaded Stencyl? Okay, good. You can go to my website. .net. So if you go to corymartin.net/Nashville, I have like this web page I put together, like this. I went all out, and there's like a bunch of different tasks that you can select that like, so you can choose whatever you want to do, and there's like instructions on how to do it. I figured that would be more fun if you can choose what you want to do rather than me showing you explicitly like specific things like now we're going to do this and follow along. So you can kind of go at your own pace and choose what you want to do. So I can pull that up here. So here it is, the Nashville Activity Zone. And yeah, so you can download the action platformer game that I just made, except it's kind of different because it's not exactly the same game. And then you can import that into Stencyl. And then, like, I've got a bunch of different things you can do and detailed instructions on how to do it. So yeah, and like at any point, like you have questions and you want me to like come over and see what's going on, like just let me know. And I would be very happy to do that.